It's everywhere, isn't it? AI is on our phones, it's in our cars, and it feels like it's changing the world faster than we can keep up. But here's the thing. To really get a handle on where AI is going, you've got to understand where it came from. And this story, it didn't start with a silicon chip. It started with a dream, an ancient one. So let's dive into the long, fascinating, and sometimes pretty wild history of artificial intelligence. Now get this. This quote is from 1726. That's nearly 300 years ago. Jonathan Swift, in a work of fiction, was describing a machine, an engine, that could generate books on any topic just by scrambling words around. I mean, how crazy is that? It's basically a description of the generative AI we are all talking about right now.
But that's exactly what it was for a very, very long time. Just fiction. A clever idea in a book. For most of human history, the whole concept of a thinking machine, of an artificial mind, really just belonged to the world of myths, philosophy, and pure imagination.
So how on earth did we get from a make-believe engine in Gulliver's Travels to the powerful models that we have in our hands today? Well, that journey is an incredible story. It's full of brilliant minds, ridiculously bold predictions, some absolutely crushing setbacks, and a few quiet, revolutionary breakthroughs that changed everything. Okay, first, we've got to wind the clock way, way back, because long before anyone even conceived of a computer, the dream of artificial beings was already ancient. It seems to be this deep-seated human curiosity, this desire to understand and maybe even recreate our own minds. For ages, this idea just stayed in the realm of myth. But then, in the early 20th century, we start to see these first little glimmers of reality. In 1914, El Ajedrecista wasn't a story. It was a real physical machine that could actually play a game of chess. And just 7 years after that, a famous play gives us the word we still use today, robot, which comes from the Czech word for forced labor. The dream was slowly but surely starting to take shape. And then things really started to accelerate in the middle of the 20th century. With the invention of the digital computer, what was once just a philosophical thought experiment suddenly became a legitimate, formal scientific pursuit. This, right here, was the dawn of the AI era. The 1950s were just an absolute whirlwind. I mean, the entire foundation for the field was laid in about 10 years. It all kicked off in 1950, when the brilliant Alan Turing posed that iconic question, can machines think? 5 years later, boom, the field gets its official name, artificial intelligence. The very next year, the Dartmouth Workshop makes it a real academic discipline. Then, in '57, we get the perceptron, a super early attempt to mimic how a brain cell works. And to top it all off, in 1959, Arthur Samuel coins the term machine learning for his checkers program, a program that taught itself to play so well it eventually beat the guy who made it. And this quote just perfectly captures the unbelievable optimism of the time. This wasn't some sci-fi writer, you know? Herbert Simon was a Nobel laureate, a true pioneer of AI. He and the other founders of the field genuinely, truly believed that human-level intelligence was right around the corner. But that huge, grand promise was about to hit a brick wall. It turned out that those early successes in clean, logical games like checkers didn't really translate to the messy, complicated real world. The hype had created this massive bubble, and, well, it was about to burst. Yeah, this slide really shows you the two sides of the coin. On the one hand, you have these incredible predictions of human-level AI happening within a generation. But on the other hand, reality started to bite back hard. Major reports came out, like the Lighthill report in the UK, that basically declared the whole field a failure. The truth was, problems like understanding language or recognizing objects were just infinitely harder than playing checkers, and the computers back then were nowhere near powerful enough. And so, just like that, the research funding taps were turned right off. And this kicked off what everyone now calls the AI winter. For years, research just slowed to a crawl. The term AI itself kind of became a dirty word. It was this long, cold period where it really seemed like the dream might be over for good. But even during that deep freeze, a few dedicated researchers kept at it, and they started to shift their focus. They moved away from trying to hand-code intelligence with rigid, human-made rules, and they leaned into a whole new idea. What if a machine could learn on its own just by looking at raw data? This was the quiet, almost secret beginning of a renaissance. So 3 huge breakthroughs really made this new AI spring possible. First, a clever algorithm called backpropagation finally made it practical to train these really deep, complicated neural networks. Then came the proof that it could work in the real world. Jan LeCun's system successfully read handwritten zip codes. And finally, you had the fuel for the fire, ImageNet, this colossal data set of labeled images that gave these powerful new networks something to actually learn from. And suddenly, the results started to make headlines again. In 1997, IBM's Deep Blue defeated the world chess champion, Garry Kasparov. Now, this was still what we'd call narrow AI. It was basically just crunching millions of moves a second, but it was a massive symbolic victory. It proved to the whole world that a machine could out-strategize the best human mind at one of our most treasured games.
But then came something totally different. In 2012, a Google research team fed a massive neural network 10 million random thumbnails from YouTube videos. And here's the incredible part. Without any human help, with no one telling it what to look for, this system learned to identify cats. It literally figured out the concept of cat all by itself. This was a huge moment for what we call unsupervised learning.
The momentum was just building and building. And then, in 2016, something happened that most experts thought was still decades away. DeepMind's AlphaGo beat Lisadol, the world champion of Go, a game so complex it has more possible moves than there are atoms in the known universe. But AlphaGo didn't just win. It made moves that top players called creative, even beautiful. It wasn't just calculating. It felt like it had intuition.
So all of these breakthroughs, the new algorithms, the massive data sets, and just sheer raw computing power, they all set the stage for right now. For this era where AI has shifted from just analyzing and understanding information to actually creating brand new stuff out of thin air. And the scale we're talking about now is just, it's hard to even wrap your head around. In 2020, OpenAI released GPT-3. It was built with 175 billion parameters. You can think of those as the little connections in the network that gets tuned as it learns. This insane scale allowed it to generate text that was often impossible to tell apart from something a human wrote. And that really kicked off the generative AI explosion that we're all living through today.
And the pace of progress is just breathtaking. I mean, think about it. In 2020, AI mastered text. Just 1 year later, in 2021, models like DALL-E were turning our words into incredible images. And by 2024, models like Sora were generating high-quality video from just a simple text prompt. In less than 5 years, generative AI has gone from text to image to video. It's just wild.
So where does that leave us? Well, it helps to think about AI on a kind of spectrum. Everything we have today, from the chessbots to the video generators, is still considered artificial narrow intelligence, or ANI. It can be incredibly powerful, but it's specialized for specific tasks. The big dream, the one that started it all, is artificial general intelligence, or AGI, a machine that's as flexible and smart as a human. And way beyond that is the theoretical idea of superintelligence. For all the incredible progress we've seen, we're still really on that first step. This whole centuries-long journey, from fictional engines to globe-spanning neural networks, has brought us to this amazing moment. For so long, the biggest question was just, can we build a thinking machine? It feels like we're getting closer than ever to answering that. But it leaves us with a new, maybe even more profound question to think about. As we continue to build these machines that can learn, what are they ultimately going to teach us about ourselves?